Welcome back to another video. Let's jump right into the topic of negative binomial distribution. The negative binomial distribution is used to model the number of trials required to achieve a fixed number of successes in a series of Bernoulli trials. In a series of Bernoulli trials, let's define X as the number of trials required to achieve R successes. The probability of success on each trial is P. The distribution describes the situation where we count the number of trials until we get exactly R successes, with the remaining trials being failures. The PMF is defined as the multiplication of combination of R minus 1 successes out of X minus 1 trials and probability of successes to the power of R and the probability of failure to the power of X minus R. The combination term accounts for the number of different ways we can arrange R minus 1 successes in X minus 1 trials. The minus 1s are happening because the last trial should be a success and should end the experiment. Probability of success to the power of R represents the probability of getting R successes. Since each success has a probability of P, you multiply P by itself R times. Similarly, probability of failure to the power of X minus R represents the probability of getting X minus R failures. Since each failure has a probability of 1 minus P, you multiply 1 minus P by itself, X minus R times. For each success, on average, you need 1/5 trials. Since the probability of success is P, to achieve R successes, you multiply the average number of trials per success by R. Hence the mean is R over P. The variance is R multiplied by the probability of failure divided by the square of probability of success. The variance tells us how much variability there is around the mean, or how spread out the number of trials required to achieve R successes might be. If P is close to 1, high probability of success, then fewer trials will be needed on average to achieve R successes, and the variance will be smaller. If P is closer to 0, low probability of success, more trials will be needed on average, and the variance will be larger. Let us go over an example together. An oil company conducts a geological study that indicates that an exploratory oil well should have a 20% chance of striking oil. What is the probability that the third strike comes on the 7th well drilled? Please pause the video here to take a moment and try answering this question on your own. The problem of interest is a negative binomial distribution problem where we want to find the probability that the third success, comes on the 7th well drilled. Key information include the probability of success, striking oil, on each well is P equals 0.20. We want to find the probability that the third strike occurs on the 7th well, which means the total number of wells drilled is X is 7 and the number of successes we want is R is 3. Substituting into the formula tells us the probability that the third strike occurs on the 7th well drilled is approximately 0.049. Here you can see how we can use Python to calculate negative binomial PMFs and visualize them. We can use the binom function to model a negative binomial distribution. Here as an example, I have calculated the probability that the third strike comes on the 7th well drilled. Thank you for your attention and see you in the next video.